This is a quick overview of Chapter 3. If you want more details, I do have videos for Chapter 3 loaded and put onto Schoology. This is the overview, not meant to be a replacement for the whole chapter. This chapter was about logs, exponentials, and logistic functions. We started the chapter by knowing how to graph these three types of functions. The first type of function is exponentials. Exponentials are a times b to the x. When your equation is an exponential, then a is your initial value. In a graph, where that shows up is going to be the y-intercept. If b is greater than 1, then your graph will be exponential growth and your end behavior will be towards infinity. If b is less than 1, then your exponential graph will be decay and your end behavior to the right will be towards 0. This graph has a asymptote of y equals 0, always, unless you have a vertical shift. So if I graph this a times b to the x, if b is greater than 1, then I'm going to start at a on the y-axis, and my graph is going to start out very small and zoom upward very quickly. If b is less than 1, then my graph will start at the y-intercept, but it will be decreasing down to the x-axis rather than increasing up. Domain is all real numbers. The range is from 0 to infinity. The range does not include 0 because this graph gets close to the x-axis without actually touching it. That's the first type of graph. The other type of graphs that you should know how to graph is you should know how to graph, at least roughly, what does the shape of the natural log or any log function look like. Your log can be any base. And the things that you should certainly know about the log graph is that 1, 0 is the x-intercept. This graph does not have a y-intercept because it is an exponential graph, but reflected because it's the inverse. So this graph would get close to the x-axis without actually touching it. So it doesn't, the y-axis without actually touching it. So it doesn't have a y-intercept. For log graphs, logs have a domain restriction. The domain is not all real numbers. The domain is from 0 to infinity. The range is all real numbers, but the domain is not all real numbers. This point is a point that you should graph on your log graph. And then the third kind of graph that you should be able to graph is a logistic graph. The logistic graph has a carrying capacity or limit to growth. And then it has what looks like an exponential function inside of it. But I want to warn you that a is not exactly the initial value. So C is the carrying capacity. The initial value would be C over 1 plus A. If I tell you the initial value, you have to do some math to figure out what the initial value, what the C and the A are. B is a growth rate for this population. At any rate, this graph is going to have two horizontal asymptotes. one of the horizontal asymptotes is going to be the carrying capacity or the limit to growth. The other horizontal asymptote is going to be the x-axis. There's going to be an intercept on the y-axis, and then it's going to curve up towards that intercept and then up towards its horizontal asymptote. That is the basic shape of the logistic function. The domain for logistic is going to be all real numbers. The range for logistic is going to be from 0 to your carrying capacity. Oops. All right. We also looked at how to write an equation for a log graph. Writing equations for exponential and for logistic. You should be able to write an equation for an exponential function given an initial and given a second point. You need both of those two things to figure out your exponential equation. You should be able to write an equation for an exponential function given the initial and given the growth rate. If you know the growth rate as a percent, then the way you figure out the initial is going to be A. The way you figure out B would be 1 plus R, but you need to change R to a decimal. So divided by 100 would be one way of saying that. You should also be able to write an equation for an exponential function given 2 points. And neither one of them has to be the initial. So it's nice if they give you the initial. If they do, then you know A right away. If they don't give you the initial, you have to be able to write it with 2 points. I'm not going to go into details here because there's another video about how to do that if you have an exponential function you're trying to write an equation. Oh, I forgot to say that you might have exponential decay here. If it is decay, it would be 1 minus R over 100. Okay, the other type of equation that you should be able to write is logistic. Logistic equations are a little bit more involved. Please make sure you watch that video. The thing you should know is that C over 1 plus AB to the X, that would be given to you. So I'll tell you that function. And then the other thing you should know is that C is the limit to growth or the carrying capacity. To figure out A and B, you need 2 more points. You need the initial position, which is not necessarily A. It's definitely not A. It's going to be, initial is going to be C over 1 plus A. And then you also need another point so that you can figure out what B is. If you are having trouble understanding what any of that means, please go back and watch that video. Logs and properties, you should be able to evaluate logs using the idea of logs are really just asking you what is at the top of the triangle. So this log function is really saying log base 3 of 81. It means what exponent of 3 gives you 81? So it would be 4 because that's the missing exponent. So you should be able to evaluate logs. You should also know that log of 100 really means log base 10 of 100. so you can evaluate that log. Um, in this section, I taught you about the log properties. There are 3 of them. You need all the log properties memorized. So you need to know that because logs are exponents, if you are adding 2 logs together, you can compress that as a single log by writing it as a product within the log. This is an equal sign, so I could also go in the other direction. If I have division inside of my log, then that's the same thing as expanding it out to 2 logs as subtraction. And then the other log property is if you have an a to the b power and you're taking the log of all of that, you can bring the exponent down in front. And that's actually really a useful skill. That's how we solve equations with logs. With exponentials. We use logs to bring them down in front. And then the other log property is the change of base. If I need to change the base, I can change it to log base 10 or natural log of e very easily. So if I have log base b of c, I take the thing that's in the basement and I put that on the bottom. And then I take the thing that's up top and I put that up top. And I can do that with natural logs as well. Okay, the big thing you should know about solving equations is that logs and exponentials are opposites. They undo each other. So when we go through the process of cleaning up our house and then blowing up the house, the way we clean up the house is by the way we blow up the house. If it's a log, we blow it up by raising it to a power, and if it's an exponential, we get rid of it by logging both sides of the equation. So logs and exponentials are going to be tools to undo each other. That's what inverses mean. For exponentials, you don't have to worry about extraneous. You might not be able, you might have to do a log base 10, even though you don't have a 10 to the x, because that's the button you have on your calculator. So you're going to use this log property to bring the exponent down. With logs, if you're solving a log equation, you have to check for extraneous because the domain for log is from 0 to infinity. So you have to make sure you're using a number in that range. If your solution is a number that would make your log negative, then it is extraneous. Then we did context problems. You should be able to write an equation for exponential growth given a growth rate. You should be able to write an equation for decay given a decay rate. You should be able to write an equation for logistic, and you should be able to use that equation to say, well, this population has a carrying capacity of C, so I know that that's the maximum that we could have. And then you should be able to find the initial value, not just by grabbing A, but by solving this for that initial value. All right. So this is a big overview of what you need to prepare for the Unit 3 test. This is not the entire Unit 3. If you need to go back, you can go over your notes for a specific question. Thank you so much. Bye.